Good day, everyone. You are welcome to Galat Science Academy. So, our next chapter in physics is dynamic. So, the dynamics is the second aspect of kinematics. Now, we have done kinematics in my previous video. Like I said, the kinematics and dynamic, they are subtopics under mechanics. So, the both of them, they deal with what? The study of what? Of motion of an object. The study of motion of an object is kinetics. The study of motion of an object is what? Is dynamic. But in kinematics, when we are studying the what? The motion of the object, we are less concerned about the what? The force that make the body to what? To move. But in dynamics, when we are studying of the what? In the study of what? Of motion of an object and the force that cause the what? The body to be what? To be moved. So that is what dynamic. In summary, dynamic is a what? Is a branch of physics that deal with the study of what? Motion of a particle and the force that cause the what? The body to what? To move. That is what? Dynamics. Is a what? Is the aspect of the physics that deal with what? The study of motion of an object and the force that is make the what? The body to what? To move. Call it what? Dynamics. In short, you can see that what dynamic is a branch of mechanics that deal with study of what? Of force. So dynamics, and under this dynamic, we have what we call what? Newton's law of what? Of motion. We have what? We have what? Newton's law of motion. And there are three basic laws of what? Of motion. In this area of physics, is deal with study of what? Force, which is what? The Newton's law of what? Of motion. And there are three basic laws of what? Of motion. The first one we have what we call what? Newton's first law of motion. We have first what? Law of what? Of motion. We have second law of what? Of motion. We have third what? Law of motion. So let's take it one after the what? The other. The first one is first law. First what? First law. So the Newton first law of motion. Before we can discuss the what? The first law, there is a particular terms that have interest in, which is called inertia. What? Inertia. Let's look at the inertia first. The terms inertia simply means what? Is the ability of an object to be in a state of rest or uniform what? Uniform motion. The inertia is the tendency of what? Of an object to be at what? Placed at rest or in uniform what? Uniform motion. That's what we call what? Inertia, in the absence of what? Of external force. So the tendency of what? Of this board to be in this place is what? Placed at what? At rest. In the absence of external force is called inertia. If a body is moving on a what? On a uniform speed or acceleration, the tendency of the what? Of that body to what? To keep on moving in the absence of external force in it, we call it what? Inner what? Inertia. And the inertia is the properties, is the mass properties of what? Of substance or of a body. That's all called what? Inner what? Inertia. So then let's move to the what? The first law of motion. So the Newton first law of motion states that every object continues state at rest, or in uniform what? Motion, unless the external force is acted on what? On it. If a body is what? Is moving, if the car is moving now, it's on uniform motion. If we don't apply brake, the car is what? Will still continue moving. That is what? First law. Or that car is what? Is moving already. So on the uniform speed, if you don't apply what? Force on what? On the brake, the car will what? Will keep on what? Keep on moving, and it will not what? Stop. That is what? Newton's first law of what? Of motion. It states that what? Every object continues state of what? Of uniform motion, unless the external force is acted on it, or if you place the what? Like this board now, you put it here. If you don't apply any external force on this board we are here, the board will what? Will continue stay at what? At this place forever. But except what? If you apply force on it and take the board away from this place to another location. So that is what the Newton first law of motion say, that what? Every object continue position at rest, or if it is in what? In motion, it will continue to what? Be moving, or else what? The external force is acted on what? On it. So, and this what? First law of motion is give all the what? The definition of what? Of force. It give all the what? The definition of what? Of force. So the yes, is give all the what? The definition of what? Of force. You know, it tell us that the force is an external agency that change the position or shape of the body. So because that what? The purpose of this first law of motion is what? Is the one that is give all the what? The definition of force as an external agent that change the what? The position or shape of the what? Of the body. So it's divine force for us. The second one is what? The second law of what? Of motion. And then before I explain the second law of motion, let me explain what we call what? Momentum. We have momentum. Momentum, we always use what? P to represent momentum. The momentum can be defined as the product of mass and its velocity. The product of what? Of mass and its velocity is called what? Momentum. And the momentum is measured in Newton per seconds, or is measured in kg meter per what? Per seconds. Mathematically, the momentum P is equal to the what? Mass times what? Velocity. This P represents momentum, the M represents what? Mass. This is what? Changing what? Velocity. This is the formula for momentum. And the SI unit is what? Is unit for momentum is kg meter per second, or Newton seconds. So after momentum, the next thing that we need to what? To treat after momentum is impulse. Which is what? I. What is impulse? Impulse can be defined, or impulse is a physical quantity which can be defined as a product of force and its short time. Impulse is what? Impulse I is the product of what? Of force and its what? Time. The impulse is what? Is I equal to the what? Ft. B is impulse, and the unit for impulse I is Newton seconds or kg meter per seconds. So the impulse and what? And momentum, they have the same what? The same unit. So the next thing now is what? Newton's second law of what? Of motion. Second law of what? Of motion. This one says that what? The force applied to a body is directly proportional to the rate of change in momentum of what? Of that body. This if you apply force to a body, the force that you apply to that body is proportional to the rate of change in what? Momentum of what? Of that body. That is what? The Newton's second law of motion. But the force that you apply to the body can move. Your force was what? Must be proportional to what? The rate of change in what? Momentum of the what? Of the body. You can have it as this form. Force is proportional to what? You know we have rate there. The word rate means what? Time. Which is what? Change in what? Momentum. If you let's change the momentum here, this force is F proportional. The change is what? This change in momentum will be what? Mass change in velocity over what? Over t. Change this proportional symbol. We have what? K equal to the what? M change in V over what? Over t. Where what? K equal to what? 1. You will now have what? F where equal to K equal to 1. M change in V over what? Over t. From this expression, you can cause what? Okay. From this expression, you can take t to this side. You have ft equal to the what? M change v. If you look at this statement very well, you will see that what? At this point here, this is ft. This is what? Mass times velocity. Where we have mass times what? Velocity. We have force times time. Back to this side here. Mass times velocity is what? Is momentum. Force times time is what? Is impulse. So you can say what? That the what? Impulse is equal to what? What? Momentum. So if you look at the impulse and momentum, they are what? They are the same. And if they are, so they also have the same what? The same units. So we can continue by proving that again, from force is equal to the what? M change V over what? Over T. From here, you can now say that what? Recall from kinematics, A equal to what? You say what? Recall that A is equal to change in velocity over what? Over T. So let us substitute for change in V over T here. So we will later arrive to what? We will later arrive to what we call what? F should be equal to the what? A. So let me call this one equation what? Equation 1, equation 2. This one is equation what? 3. This is equation what? 4. So you cannot say that what? From Newton's second law of motion, we divide force. It gives us what? The formula for what? For force as what? Mass times what? Acceleration. You can get the actual formula for force from Newton's second law of what? Of motion, which is force is equal to the what? Mass times what? Acceleration. So, and the function or application of what? The Newton's second law of motion now is what? It gives us the what? This one is give us the measurement. Measurement for what? For force. Or it gives us what? Force formula. Which which law of motion define force for us? Is force law. Which law of motion give us what? The actual measurement for force, or the actual formula for force is what? Is second law. So the next thing now is what? Newton's third law of what? Of motion. Newton's third what? Third law of what? Of motion. The Newton's third law of motion states that the action and reaction are equal and what? And opposite. The Newton's third law of motion is what? For every action, there must be a what? Equal and opposite what? Reaction. That's Newton's what? Third law of motion. So that what? For every action, there must be what? An equal and opposite what? Reaction. And this Newton's third law of motion is give us what? The properties of what? Of force. So look at the three of them. This first one give us what? The definition for force. This one give us the formula for force. The third one tell us the what? The properties for what? For force. that action and reaction equal and what? And opposites. And we have what? Application of what? Of this Newton third law of what? Of motion. So the application of what? Of Newton third law of motion, we have it what? The attraction between man and earth. Without this Newton third law of motion, the working on the earth, it will not be what be possible for us. We have jets and rocket propulsion. It's also one of the application of the what? Of Newton third law of motion. We also have a recall of the what? Of a gun. It's also what? The application of what? Of third law of motion. And we also apply the third law of motion in what? In swimming inside what? Inside pool or river. So those are, and we also have the collision between two what? Two particles. So when two particles are collide together, it's also one of the what? The application of what? Of Newton third law of what? Of motion. So, and before we move to the what? To the next aspect of dynamics, let us solve two or more questions on how to use this formula. So let us solve these 4 questions. Now, solution. The first question is this. Question number 1. We are given what? A force of 10 Newton. So the force F is 10 what? Newton. Act for 20 seconds. Simply means what? T is what? 20 seconds. What is the change in momentum of the body? So change in what? Momentum. It is what? Momentum of the body is what? Unknown. Check from equation 1 to equation 4. Which of these 1, 2, 3, 4 is a formula for momentum? Equation 1, which is mass times velocity. But in this question here, we are given force and time. Don't give us what? Mass times velocity. But you are not trying to what? To apply your senses. Look at equation 4 here, 3 here. I said momentum and impulse are what? Are the same. So the momentum equal to the what? To the impulse. Impulse is Ft. Therefore, momentum is also what? F what? Ft. So you will apply what? This formula, equation 3. And say what? From equation what? Or from the what? Momentum equal to the what? In what? Impulse. So, therefore, what do we have now? We can have that our what? Momentum equal to the what? Ft. So the momentum, now what is force given? Is 10. What is time? 20. So 10 times 20 will give us what? 200. Therefore, change in what? Change in momentum of the body is what? 200 Newton per what? Seconds. So the question is very, very straightforward. So the second question, number 2, we are given what? When taking a penalty kick, a footballer applied a force 30 Newton on the what? On the ball. Abi? So that is what? Given force there, our F is what? 30 Newton apply for a period of 0.05 seconds. Period is what? Is time is 0.05 seconds. Good. If the mass of the ball is 0.075 kg and the mass of the ball is what? Is 0.05 what? Kg. Calculate the speed at which the ball move. So our velocity here is what? Unknown. From equation 1, 2, 3, 4. Which equation is comprised of what? Force, time, mass, velocity. You can see that what is this equation what? Equation 3, which is come from here. So if that be the case, you can now say that what? From force is equal to the what? M change V over what? Over T. And we are looking for what? V. Substitute for what? For each value here. Or make V so the formula here. We can have what? Ft should be equal to the M change in what? V. So the change in V will give us what? Ft over what? Over mass. So what is our Ft? Our force is 30. Time is what? 0.05. Mass is 0.075. If your final answer will be in meter per seconds, if you press your calculator, the speed of the ball will be what? 20 meter per what? Per seconds. So the question number 3. The third question. Object of mass 4 kg. We are given mass should be 4 what? Kg. Is subjected to force this F1 and F2. We are given F1 should be 10I plus 15J, and we are given what? F2 should be 14I minus 87J. We are asked to find what? As a what? Acceleration. Before we find an acceleration, let us find what? The resultant force here. So my total force will be F what? F1 plus F2. This plus this is to give us what? 24. Alright. This plus this 15. 15 minus 87, 85, 10, 70, it will be 72, 72J. So therefore, my total force now is 72J, and we are given that what? Find the acceleration. The acceleration A is what? Is unknown. So from this expression, we know that what? Force. We call that what? Force is M what? MA. We have it here. We are looking for A. So from this expression, our A, it will now be what? Force over what? Over mass. You can have A. What is the force now here? We have 24I minus 72J. Everything over what? 4 given here. So it will be in what? In meter per second square. So if you like, you can split it further. Acceleration 4 in 2 in 24, 12. 12 in 2 again 6. Here we have what? 6i minus 72 to give us what? 18j meter per second square. This is what? Acceleration. The first question, a body of mass 10 kg is moving over a smooth surface whose equation of motion is given by relation. So, we are given what? Mass. The mass of the body is 10 what? 10 kg. Moving over a smooth surface with an equation is given by S5t and given what? S is equal to the what? 5t plus 2t square. This S is measured in what? In meter. Find the magnitude of force responsible for motion. Abi, we are looking for what? Force, which is what? Unknown. Abi, and we also know that what? Force is equal to the what? M what? MA. So let us use this equation to find what? Acceleration. By doing that, you can say what? This equation given here, we will differentiate it. That what? The what? Derivative of x times t will give us what? Velocity. Displacement over time velocity. So if we differentiate this one, we are using the differentiation 2 times 5, the derivative of what? Of 5t will give us what? 5. Of 2t will give us what? 4t. This is what? Velocity in what? A meter per seconds. Abi? But we are looking for what? Acceleration. Hey, if you know acceleration here now, we will multiply it by what? By mass here to give us what? The force that we are looking for. The next thing we now do is what? We will differentiate this one. It will be what? The derivative of what? B square x over what? The t square. Again, it will give us what? As a what? Acceleration. Derivative of what? Of 5t. Of 5 is 0. 4t will give us what? 4 meter per what? Per second. This is our acceleration. Then if we now apply the mass, the force is what? Mass times what? Acceleration. So the force there is what? Is 10 what? 10 kg multiplied by acceleration, which is what? 4. We have what? In Newton, the force will be what? 40 Newton.